Please give a warm welcome to Immersive Visualization Producer at NASA JPL, Sasha Samochina.
Hi everyone. Thank you for sticking around. This is great. I thought I was going to have 4 chairs. Hi, welcome to this talk. Hi VRLA. My name is Sasha, and the title of my talk is Discovering New Worlds. We're going to be talking about using VR, AR, and MR for space exploration. But before we really delve into that, we're going to talk about a little bit how I got into this world in the first place, which is 360s. And I'm going to give you guys some resources of how you can create your own content using NASA stuff. So, thank you for the intro. My name is Sasha Samochina. Immersive Visualization Producer is a mouthful. What does that mean? It means that I work in a lab, which I'll talk about a little bit more, that specializes in creating VR and AR for scientists and engineers specifically. I actually was trained as an artist, so I went to art school at the School of the Art Institute of Chicago. And you might ask, like, well, why am I working in a science and tech world? I don't think that art and science are mutually exclusive. I think they're actually supposed to be combined together to create these beautiful things. And so I've been calling myself a creative technologist, which I think is a cool phrase, and I think that makes sense, and I think a lot of people can use that to describe themselves. So a lot of the work that I do really kind of hinges on the idea of how do I combine art and science to make something that's both useful and educational. What is the intersectionality of art and science? I feel like this shrugging emoji when I'm asked that question. I do a lot of talks that kind of look at the answers to this. I have my own answer, and I'll kind of explain it throughout this talk of how I found my path, and hopefully it'll help you also find a path in this realm. So, NASA, the big space agency. So I'm going to give you guys a little bit of a history lesson about JPL if you didn't know what the history of it is. I think it's kind of cool before I get into what I do exactly, because I think we're kind of following these footsteps of thinking above and beyond the regular kind of norm of what normal people should be doing. So JPL is a NASA center that is in Pasadena, California. Overall, there are 10 centers of NASA all over the United States. We are the ones that do robots, so we only specialize in robotic missions to space. No humans. I personally do a little bit of work in our lab with some human factors, and I'll get into that a little bit more soon. So we're using the word jet. That seems not so cool, but back in 1936, when JPL first started, it was a more futuristic way to say rocket. They said rocket didn't sound cool enough. So JPL was formed actually 14 years before NASA started. So I'm going to show you my favorite picture of the beginnings of JPL. So JPL started actually at Caltech. So we're part of Caltech, and we're funded by government funds. So NASA is what helps us make things, but our brains are basically at the mercy of California Institute of Technology. So there were 7 guys that were really kind of crazy, and they started trying to make propulsion rockets shoot into space at the California Institute of Technology, and there was an accidental explosion that led to basically the director at the time saying, you guys have to go 5 miles away into the arroyo and do your stuff there. Fast forward to this picture. Guess which guy is the JPLer? So this is my spirit animal, this shirtless man. So he's one of the 7 guys that started JPL. They were called the Suicide Squad because of the crazy things that they were doing. Now this picture embodies what JPL means to me. All the military guys, so this is a missile testing site. That's what we first started doing before we created the first satellite for the USA. So this is before NASA started too. So they were doing these ballistic missile testing, and the military guys are looking to where the launch is happening. So where the missile is launching. The JPLer without a shirt on is looking at where he thinks it will land. So it's this idea of thinking forward into the future, and I mean, I can't get enough of this photo. So why is JPL important? We actually helped create Explorer 1, which was the first US satellite to be launched in 1958, and that was also the beginning of NASA. So it all came together. It was the answer to Russia's Sputnik. I'm originally from Russia, so I have like, I don't know what side I take in this, but I'm gonna say Explorer 1 because Explorer, humanity side, yeah, I know, I'm but a human. Earthling, to be specific. So the thing that Explorer 1 did that was really cool is it did the first science. So Sputnik didn't actually do any science. Explorer 1 actually helped find the Van Allen radiation belts, which was a huge discovery. So that was a big deal. So this is mission control at JPL. We are home to how all deep space communications happen and the home of something called the Deep Space Network. So the Deep Space Network is how we actually talk to all the things flying in space. At JPL, we call this the Spaceflight Operations Facility. People refer to it as mission control. Our former director, Charles Alachi, called it the center of the universe, which is now its nickname. So basically, this place has been occupied by someone 24/7, 365 days a year since JPL first started with NASA as an agency, and it monitors basically all activity in space. It talks to these satellites, which are part of the Deep Space Network. And there are 3 locations for these satellites. One is in Spain, one is a little bit north of here, outside of Barstow, and one is in Australia. And they're approximately 120 degrees apart in longitude, so that when something is in space, you basically never lose the signal. So the antennas turn all around the world to be able to communicate with actual spacecraft. So this permits constant communication with spacecraft and other planets as our planet rotates, so it's well thought out. So why is JPL something you might have heard of? We actually did the Mars Science Laboratory mission with the cute rover on Mars called Curiosity. It was a 90-day mission that has now lasted 5 years. You could say we're pretty good at making rovers. The other rover that we created was called Opportunity. We've done several, but Opportunity has been up there for 14 years now, and it was also a 90-day mission. She's a teenager now. She's like not calling back. No, she is calling back. So this is actually the clean room at JPL where Curiosity was built. And on the left there, that's a selfie of herself on Mars. And I actually work very closely with the data that Curiosity makes, and I will get into that in a second. So my first position at JPL had to do with the media department. I was in communications, and this is part of the NASA Charter. The NASA Charter says we have to have the widest dissemination of information concerning all activities that happen at every center. So basically, as soon as something happens, we have to tell the world how. Your tax dollars help us, and we need to pay it forward. So something happened in February of 2016 where I had these meetings in Mountain View, and suddenly YouTube and Facebook were like, hey, we're gonna have this API come out where you can put panoramas into the web. And I was like, oh, okay. We have some things like that are from Mars. So these are what we used to release as panoramas of Mars. The bottom one is what I created. I pioneered the first 360 for NASA, but when we first released it, the bottom picture is what it actually looked like. So it doesn't really make sense, but this is a full panoramic view of both everything around the rover and the rover itself. Curiosity has 17 cameras, and that's what allows you to take full panoramas. I can get into this and talk probably just about that, but there are some great videos and resources on YouTube that I'll point to our link at the end of the talk. I call Curiosity a she. All of our rovers are female. That's because we use the same kind of name as ships. So ships are female, rovers are spaceships, kind of. So we're kind of going with that. I like that she's a girl. So this is the first 360 that I created. It was really crazy to actually make this. It was February 2016, so it was really before any editing tools came out. And as I was actually editing this video, Premiere was like, oh, we're adding all this functionality. And it was really pleasant, but it was also nice to kind of engineer it a little bit and hack it together and see what I could do. So this was the first time we could really release something to the public that showed that where the rover actually was and put it into plain sight of this dune that was quite large. And it was basically something you could see from the comfort of your own desktop or your phone. So it was a big deal, and you could say that I got kind of obsessed with making 360s. We have the Juno mission that inserted into the orbit of Jupiter, July 4th of 2016. 2016, yeah. And it took 5 years to get there. This mission was crazy. 5 years flight to get to Jupiter. No one had ever been this close to Jupiter. When we were getting close to Jupiter, we were like, I don't know what's going to happen. And I was like, well, do we have any data right now that could show what it would look like if we were floating alongside the spacecraft? So with some really talented image specialists that I worked with at JPL, we created this 360. These are just GIFs, because I can't actually show you the full YouTube link because no Wi-Fi, but I'll show you a link at the end that you can see all of these videos in full force. Basically, I like to say that Jupiter is kind of the Mordor of planets. Lord of the Rings, cool. I'm not a dork. Because it has all these magnetic fields, and basically we didn't know what was going to happen. So this was a way to kind of talk to the audience and be able to show them without them actually being able to be there. There's a really cool thing on Juno, which is called the Juno Cam. Originally, they were not going to put any cameras on the spacecraft, and I think someone in the room was probably like, not everyone just likes data. People like photos. So we did put a camera, but it's a citizen outreach camera. So basically, all of the data that you see, or all of the photos that you see from Juno, are put together by citizen scientists. So anyone in this room could do it. And I think that's one of like our coolest projects. We have these groups of people that teach each other how to process the images, and it's this like really beautiful and amazing outreach project that we have. I would encourage you to explore that. So if you just follow at NASA Juno, you can learn more. This is a shot of a CAD model of inside the spacecraft, and this is the first time we kind of publicly showed something like this. You can see 3 Lego minifigures. So I told you we don't do humans, but on Juno there are 3 Lego minifigures that represent Juno, Jupiter, and Galileo. Kind of a hats off to the first time we really saw Jupiter. We partnered with Lego to do this cute little thing, and this was the way that we kind of showed people that it actually happened. So that's Juno. I'm going to move forward now to a mission that is very dear to my heart. It is called Cassini. Last year it deorbited into Saturn. So it had been at Saturn for about 20 years, and I like to say it was running out of gas. This is a visualization of every orbit that it did. And if you look in the center, those orbits are what we call the grand finale. And the grand finale was kind of the final breath of Cassini. As I said, JPLers, we're crazy. The wonderful orbital mechanics engineers that we work with realized that, okay, Cassini's running out of fuel, but let's do something crazy before we deorbit it into the planet. And the reason we did that is because if we kept going and we couldn't control it, it could basically pollute a moon of Saturn. And if we go and see something there and we find life, but we find ourselves, we have to be sure to protect other planets. There's actually a department called Planetary Protection at NASA, which is like the coolest thing to work for. So those orbits in the middle are they were called the proximal orbits, or the beginning of the grand finale. I got to sit in mission control with Dave Duty, who's a spaceflight operations engineer for the mission, and I got to help him send the first set of signals for this final grand finale. It was very touching because it was basically these daring dives that Cassini was going to do between the planet and the first set of rings. So it's basically going to taste the atmosphere of Saturn, see things that we've never seen before, get closer to the planet than ever. And you know, if it didn't work out, it was going to crash into it anyway, so we kind of took a chance. The thing is, it did work, and it was extremely special. And this was actually, I made this right before the orbits began, so this is actually before the real data came down, but this is what they were planning to do. So you're flying along with Cassini as you're looking out onto the rings of Saturn and the sun. You can't see it in this GIF, but there's a really tiny little speck left of the sun, and that's us, that's our whole entire planet. I always like to think of that when I do anything because, you know, the pale blue dot Carl Sagan quote is always my favorite, and we all have to think about things in perspective, and this project was really fun to work on. I partnered with Eric Bergquist, who's a really cool visualization specialist from Sweden. So he created this, the graphics for this, and I art directed it, edited it, and snuck in my own music. So this was a really cool project I did with the German Space Agency. This is Locator Crater, which is on Ceres, and Ceres is a large object in the asteroid belt. So it lies between the orbits of Mars and Jupiter and slightly closer to Mars. The thing about Sirius is it has these bright spots, and we didn't know what they were. So the Dawn spacecraft got really low and basically took this real data. No one cared about this data until I was like, hey, German Space Agency, do you guys want to just hand that over? And so this 360 was created where you're kind of flying over and able to see the deposits of these bright spots, which ended up being sodium chloride, basically salt, and more research is actually being done on this right now. And lastly, I want to show you an exciting thing about how people visualize other planets. So this is a visualization of one of the planets in the TRAPPIST-1 formation that was found in February of 2017. It's a system of 7 planets that was going around one single star. So it's really exciting because it's a place that's really far away that looks like something like our solar system would look like, what we call an exoplanet, way, way, way outside of our solar system. And 3 of the planets that we found and discovered using the NASA Spitzer Space Telescope actually are rocky planets that could be habitable and that might have liquids, so Earth-like planets. So one of them, TRAPPIST-1d, was based on data visualized by really amazing people over at Caltech, and we worked together to create this kind of world that you could be on. This is an artist concept, so this is not based on total fact, but this is just a way that you can take data and kind of interpret it in a different way. This is a really exciting thing to work on, especially because you're like, in our lifetime, I don't think we're going to get there, but I can get there through the comfort of my YouTube 360. So these are a couple of links. If you go to bit.ly/planetarium360, you can download every single 360 that NASA has ever put out. So that includes the things that I made, that includes every other center. I would encourage you to do that. Use it in your projects. Everything that we create is actually in the public domain. So every image, everything. So I encourage people to do things with them. And then if you go to NASA JPL 360, you will start at the series 360 and be able to kind of see all the 360s that I've shown here today. Enough about 360, because I got really obsessed with immersive storytelling, and I was like, I really need to learn the back end more. So as I was doing this, I was kind of getting curious about how the code works. How do you actually code for VR? How do you make AR work? So I started a new position, which is my position currently, Immersive Visualization Producer, at a place at JPL called the Ops Lab. The Ops Lab is kind of like a startup at JPL, where a bunch of designers and developers working on software to help scientists and engineers transform how their missions operate. So we're trying to make life easier for them by creating tools that will help them do their jobs more quickly. This is just a little video, and I'll talk over it. So these are just some of the projects that we first did. Did a lot of kind of prototyping with the first Oculus device, which I will talk about more. Currently, we're working with the HoloLens, and we do a lot of robotics kind of in tandem with VR and AR. So really experimental stuff, and a lot of it has to do with just prototyping and prototyping. We have a huge user research department that kind of does a lot of the heavy lifting. We document everything we do, and then we do some work with the International Space Station. Here's some of our team doing some zero gravity testing with the HoloLens. That was before I joined the team, but that seems like so much fun. And also we're operating procedures now, and I'll get more in depth about exactly what each of these projects is once I go through this. This is a good one. Remember that. I wish I could just show that clip when I talk about this application, but remember that clip. So, Mars. This is what people used to look at when they studied Mars. So if you're a planetary geologist for Mars, you're trying to look at rock formations on a different planet. Before, people used to look at it in this way, an anaglyph. You know, as much as I like retro, I feel like you can't really be immersed in a space when you're just wearing these. I think it's cool. I still have a lot of the anaglyphs, and we actually still do produce them, but it doesn't put you in the space. You know, if a rock is a meter, how are you going to tell if it's comparatively to another rock? How are you going to get depth? How are you going to get dimension? So in 2013, we started doing these studies with Oculus, basically kind of rigging up some data from Curiosity, doing really like kind of photogrammetry pipeline, and you'll see it here in the video, recreating some environments on Mars, and putting planetary geologists in those environments and asking them if they think that they're able to do their job better. And lo and behold, it was true that they were able to do their jobs a lot better based on being immersed in their environments. So with that, we kind of moved forward with doing a lot of prototyping and user research. And in 2014, we were approached by Microsoft, and they were actually just kind of coming up with the first prototype of the HoloLens. So we actually worked with them while the HoloLens was being prototyped to create one of the first applications for the HoloLens. And that application is called Onsight. So Onsight is a virtual walk on Mars. It is a walk on Mars that is done through both WebGL and the HoloLens, and you're able to meet collaboratively with other people. So our scientists in Pasadena meet with scientists in France and are able to study formations on Mars and make new discoveries. So in short, we enable scientists to work on Mars from their offices. And this is a really exciting thing, and I actually just made sure that this paper was true, but there were mud cracks found on Mars, which means that there was a possibility of liquid water at some point. And the first scientists to actually see those mud cracks saw them through the Onsight application. So we actually helped to kind of discover one of the main missions of the Mars Science Laboratory, which is trying to see if there was former water or possible life on Mars. Now, we don't know if there's life yet, but if there's water, we're thinking that there's probably life. So it was really exciting to be part of that research. This is just, since I can't show you a demo, this is a recreation of the terrain that we make. So how this terrain is made is taking photos from Curiosity rover and compiling with them with orbital data from the orbiters going around Mars, which have been collecting data forever. We've basically tracked all of Mars orbitally. And then we're able to make a photogrammetry terrain pipeline that auto-updates. So as soon as a downlink happens, so information down from Curiosity, about 2 hours later, it will auto-update in the HoloLens. So you can imagine this is exciting for Mars, but it's exciting for so many other reasons as well. Because now you can explore other places on Earth that you can't maybe go to exactly, or other moons. The Europa mission is going to be a really exciting mission, and it is going to explore icy worlds. And we're thinking about using this pipeline to maybe use it for our scientists to be able to see the terrain before they're actually able to go there. So this has been one of our favorite projects to work on, and we're going further and further with kind of expanding where we're going with this. Now, the second tier of this is like, okay, I'm showing you this and what it looks like, but for regular audiences, it was hard to explain this without sounding like I was a crazy person. Like, I work virtually on Mars with people. And they're like, no, you don't. So we created a couple of public outreach projects that I'm pretty proud of. Here we have Destination Mars, which was taking the same thing, the same kind of terrain pipeline that Onsight has, only a demo version. So it gives you a virtual tour of Mars with a holographic video capture of Mr. Buzz Aldrin, Dr. Buzz Aldrin, which is pretty exciting, along with JPL Rover driver Arissa Hines. This exhibit was really successful. It actually went for 3 months at the Kennedy Space Center Visitor Complex, had around 28,000 visitors. Only one HoloLens was broken the whole time, which I find to be incredibly amazing. I was like, usually museum visitors they break things, so this was an amazing feat. And it was really the first time that mixed reality was used in a museum like this on this scale, so that was a big win. But again, are you guys going to go to the Kennedy Space Center to see this? And now it's not there anymore, so we recently created Access Mars. So this was a collaboration with Google. And this is the same exact pipeline. So you can go to 3 different sites on Mars, and including the last site that Curiosity is currently in. And to date, about 15,000 hours of use have been, 15,000 hours of people have been, hold on, I'm saying that incorrectly. People have spent 15,000 hours on Mars, about. So this was an exciting project because, you know, I think WebVR is kind of this format that we're trying to make everything in now. because we want everyone to be able to experience what we make. So you can go on your desktop, you can go on your phone, or you can plug this into your browser and your VR device and be on Mars just like the scientists at JPL. So I think this is a pretty exciting thing to do. So, you know, you can brag to your friends today that you heard from a JPLer that you can all be on Mars and just dial it up on your phone and be there. Now, when I told you to remember that clip at the end of the last video, it's because it's this application that's a little bit hard to explain, but also extremely exciting and extremely complicated in all of the right ways. So the second application that I helped produce is called Protospace. And Protospace is a CAD visualization tool. So Unsafe is more for the scientists, right? I said planetary geologists and other scientists at JPL. Protospace is more for the mechanical engineers. So basically what Protospace does is take 3D models from a 2D plane and put it into the real world at full scale. So we're able to look at spacecraft and work on them, again, collaboratively, either co-located or non-co-located. So we have partners working on the Europa mission that are in Maine, and they're able to meet virtually and look at the model for the Europa Clipper and work on it together and save out models. So we basically, there's a WebGL version of this, as well as a HoloLens version. And what we've kind of figured out is we're able to render about 3 million triangles in the HoloLens, which is pretty good, by having a backend system where you can kind of take a CAD model and reduce it without losing fidelity. So we kind of have these two things working together to be able to try and make something that would take a mechanical engineer perhaps 8 hours to take, you know, 2 hours or 10 minutes. So you can really kind of reduce your model and look at it right away. So Protospace brings 3D designs into the world before they're real and solves problems before they're real. And it's really helpful. One use case I really like to talk about that is like kind of a joy is we had this mechanical engineer come and do a demo of this, and he was like, oh my gosh, where were you guys like 2 weeks ago? And we were like, we're here. We were developing this software. He basically had to do like 3 giant slide presentations to talk about how a piece of hardware just wouldn't fit into like a room. And he was like, I wish I could have just put a HoloLens on people and be like, see, it does not fit. Or a lot of times we have use cases where a person needs to see if their arm fits behind some things because it's the last thing they do before they pack up the spacecraft. And so all of these things can be done virtually. So before you machine anything, you're basically solving all these problems. Here is our Mars 2020 rover team. The Mars 2020 rover is the next rover that's going to be on Mars. You guessed it, in 2020. I promise there will be a better name for it. That's usually a contest that we have, so keep your eyes peeled for that. So Protospace really is kind of this first flavor of what we do with CAD models and models in general. And I'll talk about how we've taken that and kind of expanded it to be a little bit more complicated and also involve the International Space Station and astronauts. But before I do that, we, as always, try to make a public outreach version of anything we do. Since CAD models are a little bit complex and we can't share all of them, we created this app that just released about a month ago called Spacecraft AR, where you can interact with a few of our flying missions right now, but we're updating it to be most of our flying missions and rovers in AR. So right now you can get it on your Android device. Very shortly you're going to be able to get it on your iOS device, so please keep your eyes peeled for that. We want to make sure everyone can see this. If you do have an iPhone and you can't use Spacecraft AR right now, there's also an application called Spacecraft 3D, and we're actually taking that whole application and migrating it into AR because that's the way things are going to be, I think, for us in the future. So I promised astronauts. Here he is. So this is Scott Kelly, who is in space for 1 year. And we actually sent 2 HoloLenses up to the International Space Station to do some tests. Here you see him kind of being able to virtually look at a procedure being done through the HoloLens device with mission control kind of guiding him through it. Why would we do something like this? Well, one thing for Protospace that we are able to do is take models that are CAD models and sync them up to real hardware, and then be able to have holographic procedures overlaying on those actual models. So why would we do something like that? Well, astronauts do a lot of things up there. They do a lot of experiments, and instead of reading a PDF that's very long, that goes step by step, it's so much easier to have them kind of see the procedure holographically overlaid so they make less mistakes. They can watch it a few times, have the holostead kind of talk them through it, and then be able to author those procedures. So what we say is that we empower crew with assistance where and when they need it. And this is being taken kind of to the next step recently. Here are some just drawings that one of our really talented illustrators made of where we're going next with this. So really being able to have this kind of interaction where you're doing something and there's an alert, hey, don't put that there, put it here. Or, you know, being able to work with someone at the same time on one procedure. And why would you want to do something like that? Well, I think there's just a less of a margin of error. Not that astronauts make mistakes, but again, we're trying to make their life easier. We're trying to make it more turnkey. We're trying to make it work a lot better. And this goes into kind of a new found thing that is still using the Protospace software. Here's my team and I kind of sketching up a little bit of a satellite and putting it into inertial space. So this is an experiment we're doing just for formulation, and formulation means basically how missions are born. So when you're trying to sell a mission to NASA or have it get picked up and funded, you have to go through all of these things where you have to explain exactly why your mission needs to be shown. And visualizing is a bit difficult in 2D. So we're basically creating software that you can take really basic puzzle pieces of a satellite, put them together, and then throw them onto the planet that you're going to be exploring so people can really see how it will work. Get what? Please wait. So I'm kind of rounding out here, and I can be able to take questions in a few minutes. I want to kind of close out by saying everything is reality. This is what I think about when I think about making anything at all. I feel like I could possibly be making stuff all the time, and sometimes I need to calm myself down, because thinking and prolonging ideas is sometimes better than executing them. So in a lot of ways, like my art mind helps me inform my science mind, and some of those ideas that you never do actually, I think, help marinate other new ideas. So kind of like being artistic with constraints is okay. I'm making that an okay thing to be. I would also encourage you all to keep making things. So as I said, it's very special that we make all of these things for the public. Take our data, take our photos, make cool things. Even if it's your desktop wallpaper, I think that it's worth it. Just interact with the science as much as you can, because you'll be surprised at how much you can learn from just doing a little bit of searching on the NASA websites. And to that point, I want to close out with a quote by the wonderful Carl Sagan. He said, "Imagination will often carry us to worlds that never were, but without it we go nowhere." So again, we're making tools for scientists and engineers, but without the kind of imagination of thinking about how these things would even start, they wouldn't be possible. So I encourage you to follow JPL on YouTube. My screen name for everything is Cloud Sasha. And if you want to reach out to me personally, please do. I really love answering questions. I can point you to any more materials if I haven't explained them well enough today. And to check out more about the Ops Lab, you can visit this website where you'll learn more about exactly what we do and see some more videos. And with that, I think if anyone has any questions, I would love to answer them at the moment. Yeah. What is my favorite VR experience? I kind of have a hard time answering that because I like so many things. Recently, I did help advise on this piece, but I didn't actually make it. Jessica Brohart created a piece called Beethoven's Fifth, which is part of her Voyager VR kind of idea. So she's a former principal VR filmmaker for Google, and now she has her own company, and she basically took the Voyager mission, which has been flying and is now in interstellar space 40 years ago and launched. So 1972, first Star Wars came out, Voyager launched, beautiful. She's basically coming up with this like conceptual VR pieces of how to take the golden record, which is basically all of humanity on one record in interstellar space, and put it into VR. And she made a very beautiful piece called Beethoven's Fifth that has you in the middle of the London Philharmonic with Esa-Pekka Salonen being the conductor, and it shoots you in and out of interstellar space and in the middle of this orchestra. And it kind of uses VR filmmaking and sound, especially ambisonic sound, which was mixed by this man called Luke Allen, really wonderfully. And it's usually installed in an igloo installation, so I really enjoyed that piece recently. That's my favorite. It's also space related though, that's not fair. I like non-space things, I promise. Any more questions? No space questions. Okay, fine. Yeah? The next big thing, so as an agency, NASA really wants to go and put humans on Mars by the 2030s. And actually that's something that we're working on with this AR/VR stuff. Is I just led workshops in Washington, DC last fall about how we're going to use AR and VR in human missions. So how the long flight to Mars in 6 months, maybe entertaining people through VR, AR, putting them in their living rooms, being able to scan bodies, and let's say there's no doctor, being able to operate on someone through a device. So for AR and VR, that's my most exciting stuff. The 2020 Rover will be a great thing. It launches in 2020, not exactly sure what month yet, but it will have a sample cache return system, so we might be able to return things from Mars. And there'll be much more high fidelity cameras, which means better terrain modeling for us. Oh wait, but the most exciting thing, you guys, tomorrow at 4 a.m. we're having a mission launch from Vandenberg, which is the first planetary mission to launch from here to Mars. So at 4:05 a.m. there's going to be a rocket, hopefully, if everything clears and it's not too foggy, there will be a mission to Mars launching tomorrow, and you'll be able to kind of see it from, depending on the weather, I think Santa Barbara is a better place to view it, but this mission is really exciting because it's going to find out why Mars forms so differently than Earth. So it's going to measure the core, it's going to measure Mars quakes, because that might be a thing, and basically why we formed at the same time and why Mars formed so differently. So you'll be seeing a little bit of that in the news, I'm sure, tomorrow if it goes. Tonight. At 4 or 5 a.m. If you guys are still out partying after VRLA, you're like, oh, look, someone said something about this. Any more questions? Yeah. Well, these are the questions that we're going to be answering. I can't answer that right now in one full sentence, but I'd be happy to talk to you about it after the talk. Okay, great. Well, talk to me after. I'll take notes. If that's everything, I want to just thank you all for being here and sticking at the last speaker, little old me. Again, I'm Sasha Samochina, and I'm so happy that we got to spend time together today. Thank you.